Okay, guys, here's a back view of the lathe. We're talking about this vertical countershaft, and there's been quite a few questions about it. I thought this was a fairly common setup on these lathes. We don't see a whole lot of vertical countershafts, and you don't see a whole lot of the assemblies come up on parted out machines, but this is kind of the standard, I thought, for the vertical countershaft, even though there's other variations of this apparently. So what my setup is this is a standard vertical countershaft assembly. The questions that have come up have been about this stud. And this is the mounting boss for this is the third position on the where this mounts. And there's a stud that comes from the hole in the back of the bed right here. Comes up, it goes through this cutout in the countershaft, and there's in the casting why there's a hole all the way through. Now mine's got a dog leg in it, and this is just a half 13 piece of ready rod. The original one was, of course, a half 13 stud. It was threaded half 13 on both ends, I believe. It threaded into the hole here and then had a lock nut on it. I believe it had a lock nut, otherwise it'd be free to float there a little bit until it was locked in position. So I'm assuming we had a lock nut here. Then there's a lock nut on the other side of this, a washer. That sandwiches the casting, another washer, and another lock. And all you do is, once it's bolted on in the upper positions, why you just adjust you've got adjustment here so that you can sandwich that in between without putting tension on it one way or another, yet it'll support it on the bottom of the countershaft. That's approximately a 5-inch long stud. Now mine, I put a dog leg in it, and it's because it didn't line up exactly with this hole. So it was off a little bit. Now, when I shortened this bed up, I drilled this, but I set up a jig to align that, both here and on the end for the banjo. And I've checked dimensions. I'm very comfortable with where it's supposed to be. So I don't know why exactly we've got an alignment issue. Could have been differences in beds. You know, it may be just the thickness of this bed here may be different than what was originally set up for the countershafts. I don't know exactly what the deal is, but it's not a big deal. You know, it mounts up. It's solid. It's fine. The other two mounting points are, let me move the camera just a little bit. The other two mounting points are right here. Let me get this up so we can see it a little bit better. All right, these are our other two mounting points. There's one of these on either side. They replace the bolt that holds the back gear assembly, or the back gear brackets on either side. The back gear brackets mount with this bolt down here, and then a bolt right here on the top. For the vertical countershaft assembly, you replace this bolt with a longer one. I had reported that this bolt was actually a 1/2 inch longer to accommodate this. The bolt will actually be 3/4 of an inch longer than what was originally in there. And I'm not going to take it out, but that measures out to be, I think, a 4-inch bolt is what that ends up being with the countershaft assembly. Looks like it's a 4-inch. So that hopefully will clear that up. Hopefully that'll give a fairly good view of the back of this whole assembly. It bolts right in place, and that's where it is. I see a picture of a lathe that's been redone with a vertical countershaft assembly that's been posted on the group. That was from a 9-inch lathe. That's what it looks like to me. So it's going to be different. They mounted that assembly a little bit more over the top of the headstock itself, and that was just the way they designed that. It looks like all of the assembly sits a little bit over the top of the headstock itself, which would balance it a little bit better. Another thing that came up was somebody said that you would induce less twist, or you could possibly induce less twist into the bed with the vertical countershaft assembly. The idea being that when you tension the belt off of the back with a horizontal countershaft, why you'd induce twist into the bed. I don't think that's going to be true. I think if your bed's mounted solidly, you're not really going to induce any twist by belt tension on a horizontal assembly, because it's going to be straight back. You may be adding a little bit, but I think that's going to be minuscule, and for our applications it's not going to make a bit of difference. I think any real or perceived advantage you'd have by having the vertical countershaft in that respect is going to be offset by the fact that you've added the weight of the motor and all of this assembly up here, and induced a twisting motion by having it kind of hanging off the back of that headstock. So I don't think it's going to make a bit of difference one way or the other as far as twisting in the bed. But there again, for our applications, it's not going to make any difference, and we're not going to notice any difference in it. So anyway, hopefully that'll give a little bit better view of the back of these headstocks and the way they're set up. Downsides to this assembly and problems that I've run into. When I bought this countershaft assembly, it was an eBay purchase, of course. It had the motor mount, the main bracket, and it had the countershaft assembly itself up on the top. So those were a unit. All of the numbers matched for what they were supposed to be. The motor mount did not fit this motor. I built a adapter plate for this bigger 3/4 horse motor. I think these were probably originally set up for the 1/2 horsepower motor. So I did run into an issue right back here where the electrical comes out. Electrical control box coming out here. That actually is almost an interference with this assembly. So I think this was originally set up for a 1/2 horsepower setup, or a 1/2 horsepower motor, rather than the bigger 3/4 horse motor. It adapts over fine. There's some clearance issues. That's why my cabling runs out the top and is kind of goofy over the hanging out in space up here over the control box. So I may make some changes to that as time goes on. It works fine for now, but it is an issue. You've got clearance problems there when you go to put the bigger motor on. So just something to be aware of. I'm going to put the lathe back in place again here and get back to working on the project at hand, which is the hand control for the cross slide. So we'll come back and take a look at that stuff as we get going again. A little more progress here. I'm working on the handle for the cross feed for the little Atlas lathe, and this is the handle that was off of the turret tailstock, and I very strongly believe this is the exact same handle that Atlas uses on the turret cross slide, or the hand lever for the cross slide. Now there may be a couple of changes in it, and I'm actually going to make a couple of changes when I build mine. And this is where I'm at so far. 3/8 flat stock, 3/8 by 1. I've already punched the 2 holes in it where they go, and I've tapered this end down. 1/2 inch holes through is what was in the original turret handle. They have 1/2 inch holes in both places. When I look at the part sheet, why, what Atlas calls for is a sleeve through the bottom bigger hole, which will be a 1/2 inch OD sleeve, and it's just a straight sleeve. They signify it as, I believe that's 9/712, and it goes through there and into the linkage for the cross slide. The top hole, if it is indeed a 1/2 inch hole, they just call for a yoke pin that goes through there and hooks into the yoke that goes around it. I believe if they used this in the original configuration with a 1/2 inch hole both places, it probably had a 1/2 inch pin going through that was knurled on one end, and it just went in through that yoke, and this rode on the steel portion of it. They may have changed that and just used this handle and made it smaller to a 3/8 hole probably, or a 3/8 pin going through, and I'm going to put a 3/8 pin in it. When I build the yoke, I drilled this one for 3/8 in the middle. What I'm going to do is when I build my yoke, I'll go ahead and probably tap one side for 3/8 coarse thread, and then the other side I'll probably countersink and put a countersink or a countersunk bolt through there to hold that, so it's still pretty much flush with the outside and yet retains it. And I've tapered it down. This is my handle. I just freehanded this in the lathe. You know, I just cut it by eye. I kind of made a little template off of the original one, and this is my handle. It'll get welded on the end and then smooth through. Hopefully this has been a little bit helpful for you. If it has, why, go ahead and hit that subscribe button if you haven't already, and any comments or suggestions you've got for me, leave them in the comment section below. Thanks for taking the time to watch.